much, everyone. Sorry, yeah, I'm good. It's just I prefer to hold the microphone. It's much more rock and roll. Okay, yeah, off you go. Okay, my talk entitled The Planet That Wasn't There, subtitle How We Found That Einstein is Better Than Newton. Now, the planet in question, you might have heard of it. The planet is called Vulcan. And I'm afraid I've got to disappoint any Star Trek fans in the audience because I'm not talking about the Vulcan from Star Trek. I'm talking about a planet whose story plays a very major role in the story of science and how science works. I usually talk about the scientific method, where people come up with theories, they make predictions with them, and if the predictions are wrong, you have to come up with other theories. So let's have a look at the solar system. Hopefully you've all seen a picture like this before. You have Mercury, Venus, Earth, all the rocky planets towards the Sun, and going away from the Sun you've got Saturn, Uranus, Neptune, and once upon a time Pluto. Now all of them were discovered through observation up to Uranus, and Uranus was looked at by a guy called Urban Le Verrier, a French guy, who looked at it using Newtonian physics. Now, what do we mean by Newtonian physics? Well, obviously, it was Isaac Newton came up with it in his Principia Mathematica back in 1687, about 150 years before Le Verrier looked at Uranus. And he came up with the the law of universal gravitation, which says that everything has an attractive force related to its mass. So in Newton's classic apple, you have an apple which is a very, very tiny mass compared to the Earth, so it ends up getting attracted to the Earth. And Le Verrier made a model of how Uranus orbits according to Newtonian gravity, and he found that it didn't quite match. It didn't quite match what it was supposed to be. And he predicted that there would be a planet there influencing the orbit of Uranus. And he very accurately predicted the position of the planet Neptune. So we found Neptune through mathematics, not directly through observation. So that's an enormous win for Newtonian physics. You've got a theory, and it predicts the position of a planet. That's amazing. But Le Verrier, having looked at and discovered Neptune, he turned his attention towards the Sun and looked at the planet Mercury. And with Mercury, he found that again it didn't quite orbit the Sun as it should have done. So, instead he predicted Neptune, he also predicted that there must be a planet between the Sun and Mercury, and he called this hypothetical planet Vulcan. And there was a French astronomer called Lescarbot who reported observing it in 1859, and he went so well, he actually won the Legion d'Honneur for it, about France's highest order of merit, for a planet that just didn't exist. Various possible sightings were made, but after Le Verrier died in 1877, with Vulcan having never been found, interest sort of dropped off. A few decades later, Albert Einstein turns up, and he comes up with the theory of general relativity, which is another theory that explains gravity, but it's very different to Newtonian gravity. Now, it's impossible to explain it properly in a few seconds, so if there's any, please. But what it essentially says is that masses warp space and time, and we end up with so-called gravity wells. So here we have the satellite, which this next one, and small objects essentially fall into gravity wells made by larger objects. And if you look at the orbit of Mercury according to general relativity instead of Newtonian physics, you'll find that its orbit has no anomalies. You don't need to put another planet in there to make it work. So what we saw is Einstein essentially rewriting several hundred years of Newtonian physics. And not only did relativity work with Mercury, it works for pretty much all the planets in the solar system, which made Vulcan the planet that wasn't there.